The Icp Oes at the Molecular Foundry is equipped with an autosampler to help make elemental analysis go smoothly. It is routinely used to measure concentrations of metals in the parts per million range. When determining whether this instrument is appropriate for your needs, please keep in mind that samples containing fluorine are strictly prohibited, and the measurement of halogens and carbon are not possible using an OES detector. Before you set up to run the ICP, it's important to check that the argon dewar is supplying gas to the system. To do this, look at the switchover station on the wall and check that the in-use light is green on the right bank. If it is, then it's okay to use the dewar. If this light is off and there is a red light that says replace, then speak with the staff contact before proceeding, because you'll need to use the backup cylinders located directly next to the instrument in the ICP lab. In this example, you see that the argon dewar is in use, so it's okay to set up the ICP to run your samples. Next to the ICP, there is a backup cylinder that has been taped off to remind you that it's very rarely needed. The regulator attached allows the flow of argon from either the dewar in the other room or the cylinder. Since you will almost always be using the dewar, you will want to leave the taped cylinder alone. After confirming that the dewar has enough gas, open the black valve on the right. The delivery pressure from the dewar is low enough that it won't register on the regulator, but this is okay. Next, be sure the knob on the left is turned to the open position. Now locate the chiller under the computer and turn it on by pressing the button in the upper left. Within a few minutes, the temperature will reach 19 degrees Celsius. Check that the waste container is not too full. If it is, replace it with an empty container and attach a new waste label. This bottle is not changed frequently, so please use the staff contact's name instead of your own as the generator. On the line for generator, write Mattox, M-A-T-T-O-X, with a phone number extension 2649, Building 67, Room 4203. The contents section should say ICP, water 98%, nitric acid 2%, traces lead, indium, zinc. Do not add anything else to this standardized label, because the waste group has a list of all the standards that we use. Input the starting date with a form of month, day, then year. On the right side, check the boxes for toxic and corrosive. For other, write pH and an equal sign. You have to record the pH on the label before the waste group will agree to remove it from the lab. For waste type, select liquid. Attach the label to the bottle, and this portion of your job is done. Now let's look at the autosampler. If it is already on, you will see a green light on the top of the instrument. If it's off, close the safety cabinet door by pressing your thumb above the tab and gently sliding it down. You're required to have this door lowered anytime the robotics are moving. Then flip the switch on the back lower left under the power cord to turn on the system. Wait until the autosampler arm has stopped moving before you start the software. If it hasn't, the autosampler will not connect to the computer and you'll need to restart it. Once everything is on and ready, open the software by pressing the ICP Expert 2 icon on the desktop. If any errors pop up, immediately remedy the problem before continuing. In most cases, this simply means remembering to open the gas valve on the wall. Contact the staff member responsible if the fix is not immediately obvious. If your gas flow and chiller are okay, you will have 20 minutes to wait until the torch can be started. This is fine though, because you'll need time to set up the program. Start by clicking on the Worksheet button. In the next window, select New. Open the C drive. Select Icp Oes Data with a double left click. Open the folder with your name. Input a file name for the data you will be collecting today, and then press OK. On the main screen, you will see 3 tabs on the top for Method, Sequence, and Analysis. Let's start on the first tab and select Edit Method. In the Method Editor, you will see an Element tab with a picture of the periodic table. Here is where you will select which standards have been prepared. Remember that this ICP has an OES detector, so it's not possible to analyze every element, which includes the halogen family and carbon. Let's start this example by clicking on calcium. The ICP works by ionizing your sample and measuring the intensity at selected wavelengths. In the analysis line window, you will see the ion type, wavelength, and intensity. If a given wavelength has a high intensity value, then the OAS detector is especially sensitive to that wavelength. Unfortunately, it's very common for a wavelength of one element to overlap with the wavelength of another. As you see here, thallium and lutetium are extremely close to the signal for calcium. So if either of these elements are in the same sample, this would be a poor choice for your analysis. If you left-click on a different wavelength, you'll see that the elements that can potentially interfere will be different. So it's important to have a good idea of which elements are in your sample so that you do not get a falsely high concentration in your final analysis. We suggest selecting 3 wavelengths for every element you will be measuring. There are 2 ways to do this. First, you can left-click and then press Apply to add them one at a time. In this case, you would make your selections and then press Close. Second, you may hold down the Control key, select your 3 choices one at a time with a left click, and then press OK. Repeat this process for each of the elements you will be measuring. You'll see each atom will be highlighted in blue on the table, with all of the wavelengths listed below. Next, select the Standards tab. Next to Know of Standards, input the number of tubes of standards you will be running. Note that this does not include a blank. Under Units, click on grams per mil and select ppm from the pull-down list for each element. Insert your calculated standard concentrations from lowest to highest, going from left to right. If you have more than one element prepared in a tube, you should list those values under the column for the same standard number. If a standard is missing from your centrifuge tube, just leave it blank. In this example, 4 elements have been selected, and each tube of standard contains all 4 elements of interest. Now press Ctrl S to save and X out of this window. Click on the Sequence tab to continue the setup. On the right-hand side, press the Sequence Editor button. Enter the number of samples you will be running. This does not include the number of standards. You can also uncheck the box requiring recalibration every 10 samples. Most people don't recalibrate this frequently. Press OK, and in the pop-up window, press Yes. Look at the right side of the screen once more and press the button for Auto Sampler Setup. The image on the left is the same from the previous page and shows the layout of the sample trays located in the auto sampler, with the washing tube for the needle grayed out. By default, the calibrations shown in yellow are placed at the end of the sampler, and the samples in blue are on a separate tray. We don't have the small standard trays, so we need to move the calibrations to the holder with the samples. To do this, right-click on the calibration tube tray on the bottom and select Rack Type Not Fitted. Then do the same for the top tray. A warning will appear at the bottom of the screen because we no longer have a designated tray for calibrations. Since we are not in an industry lab, this is fine. Press OK here, then press Yes when a reminder of this warning pops up. While the system continues to purge with argon, let's set up the ICP tubing. Feel the yellow tubing on the autosampler to be sure that it has not gone flat. If it has, replace it with one of the new tubes in the drawer below the instrument. Stretch the yellow tube and allow the gray tab to catch in the front holder. Raise the securing screw, lift the white compression piece, and lock it all into place. After confirming that the tubing on the ICP itself has not gone flat, stretch both tubes and secure the blue and white tabs in the rear and front positions of the holder. Lift the compression pieces and gently snap them into place. Look to be sure that the tubing is in the right position, taking time to readjust if one or both have slipped between the compression pieces. Insert the rinse tube into a solution of 2% nitric acid. Now you're ready to flush the lines with the wash solution. In the software, click on the top icon that looks like a hammer. In the Status tab, you'll see the current state of the ICP. The HV power supply is highlighted in red because the torch has not been turned on. This is normal. The water cooler flow is okay, and the gas flow is good. If not, you'd see these sections highlighted in red as well, and will need to correct the problem. The argon filter says that service is required, but don't believe it. The software has an error that will not allow this message to be reset, so it's okay to ignore. The Peltier is at room temperature, and as soon as we reach the 20-minute mark, it will reduce quickly to -35 Celsius. I'll discuss that more later. For now, everything looks great, so we can open the Auto Sampler tab, which will look familiar to you. To flush the system with the wash solution, click on Rinse, and then the Pump Fast icon. Watch what is happening with the tubing. The pumps will first start drawing the nitric acid solution and feeding the auto sampler. Be sure that the liquid goes up the rinse tube and down to the waste. It rarely clogs, but if it overflows, you'll need to be sure to keep an eye on it. Next, watch the solution flow into the ICP. It will gently spray the solution through the nebulizer. A very fine mist will move up toward the torch, which you will not be able to see, but the majority of the liquid will drip down into the waste container. Once you see a constant flow of solution, you know that your tubing is okay. In the software, click on Stop Rinse, and then the Pump Stop icon. Now exit out of the Instrument Setup window by clicking the red box in the upper right corner. In the Sequence tab, enter your sample names in the order you will insert them into the sample tray. This is also the order in which the samples will be run. Remember that you need a minimum of 4 milliliters in your centrifuge tubes to run. The leftmost column shows you where the samples in standard tubes need to be placed on the tray. As you can see in this example on the left, we are using tray 1, starting with the blank in position 1, and ending with the sample in position 17. The tray can be removed for ease of loading. Remove the caps from your sample tubes and insert your samples starting with the blank. Be sure to use a secondary tray for spills, and never lift these acid solutions over your lap. Acid of any concentration is not friendly to clothing or to skin. You'll notice there are 4 L-shaped feet on the bottoms of the sample trays. These little feet must slide into the open squares at the base of the auto sampler that you can see here. Load your sample tray so that the first position with the blank is in the back left corner. Now, you're just about ready to start your run. Click on the hammer icon once more to enter the Instrument Setup window and look at the Peltier value. If it is still at room temperature, wait another 10 minutes before contacting a staff member for help. It's pretty common when you become more efficient at setting up the instrument to think that this number should have changed, but you haven't yet reached the required 20-minute timer from when you started the software. Once this value reaches -35 Celsius, click on the 3-lined image surrounded by yellow to turn on the torch. It will take about a minute and a half for the system to ignite, and you'll see the torch as a blue light through the window on the front of the instrument. From this point on, you must be sure that you don't pull an excess of air into your torch. This means you need to keep an eye on your wash solution and your samples to be sure that nothing goes dry during your sample run. Before proceeding, lower the door of the auto sampler. This step is required anytime the system is running so that your hands will not be hurt accidentally by the moving needle. In the Analysis tab, be sure that all of the standards and samples you wish to run are highlighted in yellow. A left click on the tube number will gray out a line so that the tube will not be run, and another click will bring it back to yellow. Once you are happy with the sample lineup, click on the green play button on the top of the screen to automatically run your samples. It takes about 90 seconds to collect data for each tube. When the run has completed, you will need to press OK in the Analysis Completed pop-up window. You'll see all of the wavelengths measured in the right side of the screen, and the concentration values will be on the left. When the standards show up as red numbers, there will be an O at the end of the number, which stands for overage. Each wavelength has a different sensitivity, and this means the particular wavelength exceeds the maximum intensity and is not a good choice for your concentration range of interest. The word uncal for your sample output means that the calibration line did not automatically fit the data to within 5%. Most users have high and low ppm concentrations of their samples. Unfortunately, with wide ranges of standards, it's difficult to get a good linear fit across the entire region. Don't worry though, this is something we commonly deal with, and it's possible to tell the software if you are interested in the high or low end of the calibration run. Above the images on the right, click on the angled line button. This will show you the calibration points for each wavelength. Let's take a closer look at the aluminum wavelength 186.168 by double left-clicking on the black box. The window that pops up displays the standards that are included in the calibration calculation, the measured intensity, the concentration you think that you prepared, and the actual measured concentration, along with the error. If a calibration line is drawn and any point has an error greater than the default of 5%, the fit will not be seen in this window. Right-click on the black portion of the screen to enter the method editor. The aluminum 186 wavelength is the first line. Since I expect the actual concentration of my samples to be close to 40 ppm, we can omit the 1 ppm standard. To do this, I insert 10 as the minimum concentration and leave the maximum alone at 82.5 ppm. To save, I can press Ctrl S on the keyboard or use the pull-down under File to press Save. I have the option to increase the maximum error percent or to force the calibration through the blank by checking this box, but in this case, removing the lowest standard should be enough. You can see here that almost all of the samples for this particular wavelength have been given a concentration value with the exception of the sample in tube number 9. The "-x" means that the actual value is higher than the maximum value included in the calibration line. In this case, the actual value must be greater than 75 ppm. Sometimes you'll see a "-v" instead of a number, which means that the actual value is below the lowest concentration standard. And a small negative number in red is the system's attempt to calculate a value that is close to, but still below, the lowest standard used in the calibration line. In most cases, the value should be 0, but is a little off because of the calibration line calculation. Repeat this process until you have all of the data points for your samples. To export, click on File, then Export Settings. Select the items you wish to be displayed in the output file on the right. Press Browse to select your destination folder, and then click on Export Now. This will give you a CSV file. To be honest, I rarely use this file type myself because it can be difficult to view. My personal preference is to use the export settings to select what will be displayed, and then go to File, Print, and Save as a PDF. If you have not done so already, turn off your torch by pressing the icon with 3 lines under a red X. This can be done as soon as the analysis has been completed. Before disconnecting the tubing, it's important to flush out all of the solvent. Remove the tube from the wash solution. Then press the hammer icon and select the Auto Sampler tab. Turn on Pump Fast and rinse. After about 5 minutes, the tubing will be dry. Stop the pump and the rinse. Then release the tubing from the auto sampler. And release both sets of tubes on the ICP itself. Turn off the software after saving your data, then power down the chiller. Close off the argon supply to the dewar, sign the logbook, and you're nearly done. Please do not forget to dump any residual solvent into the waste stream under the instrument, and after your centrifuge tubes have dried, dispose of them in a step can. That's about it for the ICP. If you have any questions, please contact a staff member. We are always here to help.